So last time, last Wednesday, we discussed velocity acceleration position in rectangular coordinates or in Cartesian plane or in Cartesian coordinates. And we derive the position, the velocity, and the acceleration of the point, yeah, of a particle, okay, with some position r, velocity v, and acceleration a. So now we will go to another coordinate. So we have this plane polar, okay, plane polar coordinates. Uh, Share screen. Okay. So next to Cartesian coordinates, we have this plane. Uy, ano to? Okay. Wait. Okay. So we have this plane polar. Let's now go to plane polar coordinates. So plane polar meaning this is in two dimension. Okay. Kung dungagan nimo another coordinate, we call that one as spherical coordinates. So plane polar lang sa ta, no? To and then we will generalize this to spherical coordinates. So in plane polar, we have to take note, no? I-recall na to, the important properties Cartesian coordinates. In Cartesian coordinates, E1, E2, E3 are constant in time. So meaning when you take the derivative, the time derivative of E1, E2, E3, that will be equal to 0. So that is why instead nga 6 terms ang imuhang velocity and acceleration, ang makuha na lang nimo is tulo na lang ka terms because the derivative of E1, E2, and E3 are 0 because they are not constant in time. So sa tanang coordinates, ang Cartesian coordinates lang ang iyahang unit vectors kay constant in time. Okay? Take note of that. Ang only the Cartesian coordinates lang kaning I hat, j hat, and k hat or e1, e2, e3 are constant in time. The rest, say for example, spherical, polar coordinates, cylindrical coordinates, ang iyahang mga unit vectors are not constant with respect to time. So only the Cartesian coordinates. So that is why makuha kag e1 dot equals e2 dot e3 dot which is equal to 0. Okay? So ang 1, 2, 3 are in Cartesian coordinates, no? So na pwede kang mogamit og I hat, j hat, and k hat. So take note of that. Now, let's now go to plane polar coordinates. So mo ni ang plane polar. So in terms of plane polar, it means na ang imuhang coordinates are in terms of r and theta. Okay? In spherical, dungagan lang nimo ang plane polar of phi, okay? Na kung another coordinate sa phi, then that one is in spherical coordinates na. So plane polar is just in two-dimensional space lang. Okay, so let's now kung lantaw na to ni nga figure 1.16. Okay? It's not already. Okay, so as you can see here, this is now in plane polar in terms of r and theta, not in terms of e1 and e2 ha. So the coordinates that we're going to use is r and theta. So it means that the unit vectors are the unit vectors in plane polar are er and e theta. So take note of that. So these are the unit vectors in plane polar coordinates. In plane polar coordinates. Okay? And we have to take note that ER and E theta are not constant in time. So meaning mag-change siya or na siya mag-change siya with respect to time. So take a look at this figure here. Uh, a point a point P for example moves along a curve ST. So asa mga ST ani? So muna ST no? So na ko'y point, galihok siya or ga-move siya say from P.1 to point 2 following this curve ST here. Okay, so nasa motion, that is point from point 1 to point 2. Now, how will you derive the position vector of this particle that is moving from point 1 to point 2? Also, the velocity and acceleration. Why problema sa velocity, why problema sa acceleration. As long as kabalo ka mukuha sa R vector, okay, mura man na importante, no? Once kabalo ka sa R vector, position vector R, okay, position vector R, makuha nimo actually ang velocity, makuha po nimo ang acceleration sa kaning imong system. Okay? So we consider this one where the ER, take note, is ER is the unit vector along R. So we call this one as R hat. Kung kadumdum ta sa una, natay gitawag ng R hat. So muna siya ang ER, no? So lahi lang ang notation atong gamit. So this one is somewhat muna atong R hat. And then si E theta is actually your theta hat. But ang atong notation is we will use ER and E theta, not R hat and theta hat. Okay? So ER is the radial direction. Okay? ER is the unit vector along the radial direction. So meaning kanino, if this is my point P, then the radial direction is kaning araw nga green blue na to. The radial direction is going to that one. Okay? So this one is my ER. Meaning sa unit vector ha, kay take note ang iyang magnitude is 1. Okay? Basta unit vector, the magnitude is 1 and the direction is radially, it's either radially outward or radially inward. That's ER. For theta, theta and ER, E theta and ER are mutually perpendicular. So if this is your ER, then the direction of your E theta is going to this direction. So this is now my E theta. As you can see here, muna ako ang E theta here. And they are mutually perpendicular. Okay? Meaning if you dot product ER and E theta, meaning the dot product of these two unit vectors is equal to 0. Okay? Is equal to 0. So now, you move from point 1 to point 2. Okay? So at point 1, this is my ER. So I call that one as ER1. Okay? So meaning ana is the radial unit vector at point 1. And I also have E theta at point 1. So na ko'y kaning blue ba ni? Sky blue o kaning red nga gi-color na ko, no? Now, at point 2, take note si ER is changing, tama ba? Si ER2 now, kung lang taon nimo, kung lang taon na to, si ER2 is now going to this direction. Okay? Is now going to this direction here. And also the theta is also E theta 2 at point 2 is going to this direction. So muna yung gingon ganyan, no? E theta and ER are not constant in time, meaning mag-vary siya from point to point, mag-vary siya from time to time. So that is why the unit vector and polar coordinates are not constant in time, so meaning nasa derivative. Okay? Nasa time derivative, sorry. So nasa time derivative. So what will be the expression of my time derivative of ER and my time derivative of A theta? So muna atong unahon pagkuha. So muna no, when you change the motion, when the particle is moving from point 1 to point 2, then we can get the arc length of this, na ko'y RD theta, okay? So RD theta is just the arc length of this one, the FDS, okay? And then the unit vectors are changing. So na ko'y from ER1 to ER2, and also the theta vector, from E theta 1 to E theta 2. So what will be the time derivative? So ER and theta are orthogonal, but they are constant in time. Orthogonal meaning perpendicular silang duha, no? ER uh, ER and E theta are orthogonal, okay? But ER and theta are not constant in time. So using the concept of arc length, the change d theta and der, makuha na to actually ang expression ngayon eh. Based from the figure, we can actually get this. The change of er is equal to this d theta e theta, while the change of e theta is equal to the negative d theta er. So we have this based from the figure, makuha na to ning change in er and change in e theta. Kung Cartesian coordinate ni siya, then there is no change of the unit vectors. But since this is in plane polar coordinates, then there is a change of our unit vector er and our unit vector e theta. Now, if we divide this by time, okay, if we divide this by time, divide by some change dt, what we'll get is this. Na ko der dt is equal to, butanan lang ako dt dre, no? Na ko dt e theta. So this is basically equal to theta dot e theta. Sakto ba? Theta dot meaning basta galing dot kay first derivative mo siya with respect to time. So this one actually, kani siya actually is just equal to theta dot. Okay? Time derivative of my theta. Also, sa ako ang d e theta dt is just equal to minus d theta dt er. So this is actually equal to negative theta dot er. Okay? So this is now my this is now my change of e theta, okay, with respect to time, and change of er with respect to time. If I wrote this in terms of that, walang taon ako, pwede na ko ni siya isulat in terms of that. So this is actually equal to, yan eh. Okay, pwede na ko siya masulat. Si der can be written as kani siya si der, you can also write this as er dot. Tama? So na ko er dot equals theta dot e theta, and also this one e theta dot is equal to negative theta dot er. Okay? So we successfully derived the change, no, the time derivative of our unit vectors er and e theta. Okay? Again, in Cartesian coordinate, that this is equal to 0. Okay? E1 dot, E2 dot, E3 dot are zeros. But the er dot and e theta dot are not actually equal to 0. So na siya time derivative because dili constant with respect to time ako ang unit vectors in terms of plane polar coordinates. So now we have this. Ako negative theta dot er, theta dot e theta. So we can actually write the velocity, the position, no? The position is actually equal to this. In plane polar, okay, in plane polar, the position r is just equal to this one. Nakoy r, some distance or some magnitude r, the direction is actually er. Okay, the direction is actually er. Okay, so this is my position. This is now my position. Okay, this is now my position. How about my velocity? Once kabalo ko sa position, no? Once kabalo ko sa position, makabalo ko sa velocity. What is now my velocity here? Velocity is just equal to r ni siya, ha? R ni siya. R. Okay? Velocity is just equal to r dot. Okay? Pwede na ako dili butang karo, ha? So this is just equal to dr dt, which is equal to the time derivative of this nakoy r er. Sakto? Nakoy r er. So when you derive this one, this has two terms. So my velocity is equal to, sige daw, unsay derivative ani kani kisa ito si Arnel Horomo. Arnel Horomo. Tama? Tama si Arnel Horomo?
Tulog.
Wala si Arnel.
Nasa.
What is the time
Okay.
derivative of RER? It has two terms ha. Nakoy using product rule. Unsa man ang ako ang derivative ni RER? Arnel?
One, sir. Kanang sa ganin kanang theta lagi theta r e theta r e theta, sir.
Nauna may theta, wala may theta ani, di ba?
Ay, yes, sir. One, sir.
Saan gani pag-derive? Basic derivatives naman eh, no? Sakto ba? How to derive this one with respect to time? Pag-derive na ko ni. Ilaan sira ni. Ano this is equal to, it has two terms now using product rule na ko'y R dot ER plus R ER dot. Sakto ba? Tama no? Derive niyo mo isa, tapos plus i-derive na po mo ang isa ka function, ER. Since ER dot is not zero, so dili siya mag-cancel out. So it means that this one, if you expand this, na ko R dot ER plus R, your ER is actually, si ER, kaya muna ito itong na-derive yan, ano? Si ER is just equal to this. So therefore, na ko R, which ang ER na ko is equal to theta dot E theta. Theta dot E theta. Okay, so therefore, my velocity is actually equal to R dot ER plus R theta dot E theta. And notice here, this one is common, and I think naagian na ninyo ni siya nga expression sa una. I don't know if naagian na ba ninyo sa una. Sa rotational motion, as you can see, sa rotational motion, the first term is actually the radial equation for velocity, and the second term siya, the second term is actually the angular velocity. Okay, so this one is your linear velocity. Okay, the first term is your linear velocity, and the second term is actually the angular velocity. Kadumdum mo sa una sa rotational motion that the angular velocity is equal to R omega. And actually, this omega is just equal to theta dot. Okay? Kung kabantay mo sa una, si omega is just equal to the change of theta with respect to time. But and this change of theta with respect to time is actually equal to theta dot. Okay? So this term r theta dot is actually your angular velocity, and the first term is actually your linear velocity. So it is a combination of the linear velocity and the angular velocity. And look at that, the directions na ko ER, radial direction, radially inward or outward, depende sa imong magnitude, sa imong velocity. Plus, the rotational, of course, as you can see here, kung lantanin mo sa figure, your particle is moving from point 1 to point 2, and actually, if you extend that one, makakuha kag actually rotational nga motion niya nga part. So na ko'y duha ka term for this motion here. In plane polar, we have the linear velocity and the angular velocity of the particle. So ito, this is the saan ako? Okay lang, no? R Dili na nakabuta. Dili na lang sa sunod. R theta R R dot theta, R dot ER is the linear velocity, and R omega dot R theta dot or R omega E theta. So going to the theta direction is my angular velocity. Okay, so it has two terms here. And okay, so r theta is kana, so we call that one as angular velocity. Now, we now we now have the velocity of the particle. So we now have the velocity of the particle, which has two terms, the linear and the angular velocity. We can also get the acceleration. Then the acceleration, the acceleration is equal to this. A is just equal to r double dot, tama? R double dot, or this is just equal to v dot. So this is just the change, the derivative of v with respect to time. So therefore, a is just equal to the time derivative of v, which is, kopyahan lang ako ang v, no? V is equal to this, r dot er plus r theta dot e theta. Sige daw. Expand daw ni Palihog. Kinsa sunod ni Arnel. Arnel Oromo. AB. Galos? Galos ba? Tama. Sakto ba? O, dili human si Galos. Human si Galos. Sunod ni Pagayon. Pagayon. Nasi Julius?
Yes, sir. Yan, nanay.
Sige daw, expand daw ni Julius. I think this has 5 terms. Yeah, this has 5 terms. If you expand this one, na ako makuha nga 5 ka terms. Sige daw, paki-expand daw ko, Julius.
Anak ko yung final answer, sir.
Yeah, sige daw.
Acceleration is equal to
Acceleration is equal to
r double dot e
R double
sub
dot
r
E sub R
plus e
plus
sub r dot
E sub R dot
r dot
R dot E sub R dot. Tama
Yes.
na? Plus
tapos r
R
theta dot e dot
E dot. Yan na. Plus
yes plus r
R
theta double dot
theta
theta.
double dot E theta
E theta.
plus
theta dot e theta r dot.
R dot E theta. Sorry. R dot theta dot E theta.
E theta, yes.
Okay. So this is the acceleration of the particle in plane polar coordinate. So it has 5 terms, but I can actually reduce this one because I know what is ER dot. I also know what is E theta dot. Okay. So pwede na ko siya sulat actually in 2 terms lang with some close parentheses na ingani. So I have, so if we expand this one, na ako ingani, no? Acceleration is equal to r double dot er plus r dot. Kabalo ko sa er dot, no? Er dot is just equal to r theta dot e theta. Sakto? Si er kay tama? Er dot kay sakto siguro, no? Er dot is equal to theta dot e theta plus r theta dot, my e theta dot is equal to theta dot er, pero negative na siya, no? This is negative. Tama? Because e theta dot is negative theta dot er. Okay? E theta dot is equal to negative theta dot er, while er dot is equal to theta dot e theta. Okay? Negative. Okay. So I have that. Plus this. Kopyahan lang ako, no? R, dili sa dot. R theta double dot E theta plus R theta dot R dot theta dot E theta. So, nakoy do ka terms lang ani. i-regroup na ko ang ER. Okay? I-regroup na ko si ER, na ko ER, na po ko ER dere. Okay? And then i-regroup po na ko si E theta. So na ko E theta, and E theta. So therefore, the acceleration now, if I regroup that one, na lang ko duha ka terms, okay? So the acceleration is equal to this r double dot, sorry, r double dot minus r theta dot square er plus r theta double dot plus 2r dot theta dot e theta. So tanawin mo no, si er kani ER no, nakoy ER, napukoy ER, so nakoy R double dot, nakoy coefficient ka R double dot minus R theta dot theta dot theta dot theta dot is theta dot square. Okay, so that's why nakoy R theta dot square dira, and kaning tulo nakoy R theta R dot theta dot plus R dot theta dot, that's 2. So that's why nakoy 2 dira no. That's why nakoy 2 dira. Okay, so this is actually the acceleration of the particle in plane polar coordinates. And it has two terms. Nasa radial acceleration and also nasa angular acceleration. Dili kay sa familiar pero nabalik na ni siya actually. Naana ni siya sa ato ang rotational motion nga part um sa physics 41 actually, no? So naa siya kaninga term is the radial component, the r that minus r theta dot square is my radial component. Okay? Component. While the r theta double dot plus 2r dot theta dot is actually the angular component. Angular component. Okay? Angular component. Sometimes, this r theta dot kani siya can be rewritten as this 1/2 this is 1 over r d theta d dt. Magamit na to sa later, no? Magamit na to na sa later sa katong when we solve for the energy for planetary motions, energy equation of a planetary motions. Magamit natin sa actually later. Kani nga expression here na koy r square theta theta dot. Okay? As you notice here, if you derive, equal lang ni sila, no? Equal lang ni sila, no? Kani siya ka equal lang siya aning 1 over r d dt r square theta dot. Tama ba? Maklaro ba nga equal sila, no? Maklaro naman sila nga equal, no? Because kung lantaw ni mo, nakoy 1 over r, take the derivative of this, nakoy 2 terms ani, so nakoy 2r, r dot, theta dot, plus r square theta double dot. So this is actually equal to 2r dot theta dot plus r theta double dot. So they are the same actually. So the same lang dapat sila. No? So why nganong gi-emphasize na ko ni, because later kung maadto ta sa Kepler's law, kung makaabot ta sa Kepler's law, magamit nato ni actually ni nga identities ani. Nga kaning identity. Okay? So sa to na ko acceleration nga this one, we have two components, na ko radial components, and I also have angular components. And look at this, r double dot is actually my linear acceleration, and my theta double dot is my angular acceleration. Okay, ang gamit nato sa una sa theta double dot is kani alpha. Alpha is just equal to theta double dot. Okay? Sa rotational motion nga part di siya, no? Omega sa una, ang gamit nato is omega, which is just equal to theta dot lang sa karon. Okay? So theta double dot is my angular acceleration, while r double dot is my linear acceleration. And actually they have relationship. As you can see sa una, the linear acceleration is actually equal to r alpha. Okay? Linear acceleration is just equal to r alpha. So if you write this one into kaning double dot nga mga form, you can write this as r double dot is equal to r theta double dot. Okay, r theta double dot. Okay, so we successfully get the velocity, the acceleration, the position of a particle in plane polar coordinates. Okay, in plane polar coordinates. Now we will generalize this into um, spherical coordinates. Okay, we will generalize this into spherical coordinates. Okay. Example sa ta, no? Example sa ta. Okay. Itatag sa'yo ng example. Circular motion, for example. Circular motion is a good example of motion in plane polar coordinates. Pero pwede po mo gamit o Cartesian coordinates. Pero masayon siya kung gamitan nato siya in plane polar coordinates. Circular motion. Okay? So, in circular motion, so nakoy nga no? Nakoy particle, and this particle is moving pana. Okay? With radius r here. Okay? The position vector here, the position vector in circular motion, as you notice here, kung lang taon mo ang iyahang form, iyahang ang forma sa imong motion, it is actually equal to this. Some constant sine omega t di na lang ni. Sige, kanina, okay ra. Nakoy r is equal to b sine omega t e1. This is actually in Cartesian coordinates. Okay, in Cartesian coordinates, sorry. So, nakoy Cartesian coordinate lang. Omega t e2. Okay? But you can solve this one in terms of plane polar, or you can write this as sum radius times er. Okay? By the way, the radius here is not r but b. B. This is b. Okay, this is theta. Okay? Klaro ba? B theta. Ito na ka. I-erase mo na ka. Okay, so the radius of this one is b, and then the angle is some theta. So we can actually get the x component and the y component of this r. Okay, the y component and the x component of this y. So this is probably e1 here, and this one is my e2 here. Okay, so that is why na ko b sine omega t plus b cosine omega t e2. Okay, and if in terms of plane polar, this is actually equal to b er lang. Okay, so na ko b er lang. Okay, if I use Cartesian coordinate, I can solve for velocity. So because velocity is just equal to r dot. Okay, r dot lang. Ang v kay r dot. So if you derive r, makakuha ka nga ni, no? So kung ako b omega cosine omega t e1 plus minus. I think it's minus because derivative of cosine is minus sine. So ako minus b omega sine of omega t e2. Okay? And then so we have next is you can actually get the velocity, and the magnitude of velocity is just equal to the square root, right? Square root. Kung kuhanin mo ang magnitude of velocity, this is just equal to the square root of b omega cosine omega t quantity square plus the negative b omega sine omega t quantity square. And as you can see here, this is just equal to b omega. Tama? Sakto ba? B omega ram no? Kay mabilin kay nakuha no? Square root of cosine square omega t plus sine square omega t. This is just equal to 1. So therefore, the magnitude of my velocity is actually equal to b omega. Okay? If you use polar coordinates, okay, if you use polar coordinates, if you derive this, kani siya kay Cartesian mo no? If you use polar coordinates, dali lang, no? The r dot, from here, the velocity is just equal to r dot. So na ako'y ber dot, which is equal to b theta dot e theta. And what is theta dot? This is just equal to b omega. So same lang gyapon sila og same ra magyapon sila og answer. Masayon lang siya solvon in plane polar coordinates. Okay, in plane polar coordinates. How about the acceleration? Acceleration is just equal to minus acceleration is just equal to this derivative of velocity. So na ko derivative with respect to v na ko kay kani ako b omega cosine omega t e1 minus b omega sine omega t e2. So this is actually equal to b omega square sine omega t minus e1 minus b omega square cosine. Anong na omega square kay na kay? Anong na omega square gali ni Cesar di pagayon gani pagayon. Ano to? Pilyerin. Tama ba? Pilyerin. Hagi ka ng omega square pilyerin.
Paggawas man ang isa sir constant ang W so gi times siya angular sa siya angular velocity mo siya sir.
Oh.
Mo sir mo na squared siya sir.
Kaya gano'n ba ito?
Gi-multiply og isa ka angular velocity bagay sir. Zero. Kaya gipagawas mo siya constant sir.
Okay. Constant siya sa imong sinusoidal function, no? Tama ba?
Yes sir.
Because derivative of sine omega t is equal to cosine omega t times omega. Nakoy omega nga makuha, no? Tama ba? Okay, sakto, no? So I have a equal to if ako aning ipagawa si minus omega, ang nabilin is b sine omega t e1 plus b cosine omega t e2. And what is this kani? This is just equal to r vector r. Okay? So therefore, acceleration can be written as minus omega square r vector r. So you can write your acceleration as this. Okay? And if you use plane polar, dali na lang kayo, no? If you use plane polar, itita mo na siya, no? Okay? Itita na siya. Ano ko ibutang? Dali lang ako ibutang. In plane polar, so na ko r is equal to b er v while the acceleration will be omega. B and omega are just omega is not constant with time. So na ko b omega, tama? Okay? E theta plus b omega e theta dot. Sakto? Or save ko na? May save. Okay, omega square. Omega omega is just constant. Sakto? Omega is just constant. So, pwede na ako nang masulat as this. So, na ko acceleration is equal to b omega e dot But E dot is equal to, take note, E dot is equal to theta dot negative ER. So na ko'y negative theta dot ER, but theta dot is actually omega. So na ko'y negative B omega square ER. So na ko'y na ko'y ngani na yun. So na ko'y acceleration is equal to negative B omega square BER BER. And what is BER? This is just equal to R hat. R vector R. So nakoy minus omega square R vector R. Okay? So nakoy minus omega square vector R. So naiuban nga sayon sa solvon in plane polar kaysa sa Cartesian coordinate, kay expand pa man nimo ang Cartesian coordinates in 3 or 2 dimension. If you use plane polar, instead of using two variables, mugamit lang kag isa ka variable lang. So na lang ko isa ka term lang nga, or na lang ko isa ka term sa imong function. Sa imong pag-solve sa acceleration, velocity, and position. Okay? Question? Okay ra?
Oksa, sir.
Extra na? Okay, last example, then we will have a seat work. Example. A honeybee owns in on its hive in a spiral path. Okay, so ang iyang motion is in spiral path such that the radial distance is actually equal to this, such that the radial distance is equal to b minus ct, meaning from time to time magkagamay imong r. Kung lang tawon nimo ang equation na koy b minus ct, where b and c are constants, b and c are constants. Okay? As you can see here, if you graph this one, if you graph the r, ang mahitabo kay ang iyang forma is may ngani, no? Dako kay nga r, tungod sa magagamay from time to time. So muna ang path nga giagian ni kaning b. Okay? So na siya spiral path, and the equation is actually equal to this one, where b and c are constants or coefficients, okay? Which is constant. So na koy r is equal to b minus ct, while decreases r decreases at a constant rate. So take note of this, at a constant rate. The angular speed increases. So while the radial distance decreases, the angular speed increases at a constant rate of this theta dot equals k times t. Okay, meaning nagkagamay mong r tuod pero nagapaspas pud ang dagan sa imong angular speed. Okay, so the theta dot is actually equal to kt, where k is also constant. Okay, k is some coefficient which is constant with time. Now, question is find the speed as a function of time. So question is find the speed as a function of time. Okay? This is very simple. Why? Because given si r, given po si theta dot, constant rate ng theta dot, among r is also constant with respect to time. Okay? Makuha na ko ang speed, okay, as a function of time. Because I know in plane polar, my v is actually equal to nakoy do ka term, no? Nakoy r dot er plus r theta dot e theta. So I know the velocity of this function in plane polar, which is equal to this r rer tapos ako'y r theta dot e theta. Ang ako lang buhaton is just derive. Okay? I-derive lang ako. R dot. Okay? Si R dot is just equal to the derivative of R. Okay? Which is equal to this. So itong R nako B minus C T. So pila may derivative ani? This is equal to minus C lang, no? Tama ba? Minus 0 na siya, no? And theta dot is given, which is equal to k times t. So therefore, the velocity is equal to r dot, which is equal to minus c er plus kining r, which is given na ako'y b minus ct. R data is also given, this is equal to k times t e of theta. So this is now my velocity, the velocity of the function, but ang atong gipangita is the speed. Ang saan gipagkuha sa speed gani? Speed is just
Square root, sir.
okay. The square root of this,
And
the square root of the components of its velocity. Okay. So I have therefore the speed is nako yan, square root of component square. So nako yung minus c square plus unsa ito kt b minus ct quantity square. So my speed is equal to square root of c square plus k square t square b minus ct quantity square. So therefore, the speed of unsa paspason na sa function of time, the answer is equal to this one. Okay? The answer is equal to that one. So kana lang, no? Sayo na kayo siya, no? How about the acceleration? Dali na lang maghihapon acceleration. Acceleration has two terms. Okay? Makuha ba ni mo acceleration ani? Makuha, no? Makuha na, no? Because given is that the r is equal to this. Okay? Your theta is also equal to theta dot, which is constant at constant rate. Okay? At constant rate, makuha na ko acceleration. So I have acceleration equal to r double dot minus r theta dot square er plus r theta double dot plus 2r dot theta dot e theta. What is r double dot? R double dot is equal to 0. Why? Why isa sunod yung pilihan yan. Pilihan P Q R sa Torre, Juliana.
Murag
Ay,
ako,
Kim,
sir, Q.
Tama na na Kim. Kim, no? Why is it that r double dot is 0?
Constant mang gudtong sa R dot.
Okay,
Negative
so
C na lang man siya, sir.
tama, no?
So,
Sakto, no? Since your r dot is minus c lang, then r double dot is 0. Okay. So r double dot is 0. Theta, how about theta double dot? Theta double dot is this one, no? Theta dot. Okay. So this is actually equal to d dt of, this is given, theta dot is kt. So therefore, the theta double dot is equal to k. Sakto? So the theta double dot is equal to k. So therefore, makuha na ako ang acceleration which is equal to this. Kani, ma-zero ni siya. So I have minus r. R is equal to b minus ct. Tapos, ang theta dot na ako is kt. Quantity square, er, plus, r is b minus ct. Tapos, r double dot is equal to k. Okay, take note. R double dot is equal to k plus 2r dot. So, yung r dot gani, minus c, no? So, nakoy minus 2c. Theta dot is kt. So, this is equal to times e theta. So, the acceleration of the particle, of this b, the motion of this b is actually equal to this form here. Okay? And then, kung kuhanin mo ang magnitude, just take the square root of the square of this, the radial component plus the square of the angular component of the acceleration. And that's it. That's the kinematics of this honeybee motion. Okay? Question? I guess dira lang tataman. Time naman po. So, your seat work, I will post your seat work right after this one. Di na magklase si Ma'am Hazel ninyo karon. So, wala may klase. Kaya holiday daw. Okay. Wala yung question? Okay na?
Ma'am, sir.
Okay,
Kira sir,
so
Kira kay
again,
sir.
I will, okay, wala na, no? So, I will post your seat work today. Assignment na lang, assignment today para ipasa nyo karong Wednesday. Okay. Wala yung question. See you next meeting. Bye-bye.
Thank you, sir.
Ay, attendance. Wala kayong absent, no? Wala kayong absent. August 2030. Okay, bye-bye.
Bye. Thank you, sir.
Thank you, sir.
Thank you.
Ako na din grabe.